And so there's one last thing we want to do. Having completed some techniques of integration using Maple, let's also look at some simple commands to study sequences and series in Maple. Right. And so for this problem, the first thing we want to do, well, let's again restart everything and add our usual commands. And I'm going to add one more this time. I'm going to use with plots. Okay? Because I want to actually plot a sequence at some point. The first thing we want to do is define a sequence, though. And here's how we define a sequence. I'm not just going to define it like, say, this. Okay, this is fine, but I'm going to go one step further. Because if you see, right now, I've just got A, and I can say where it is, where it came from, etc. But I want to do a little bit better. I want to be able to use something like this and have it know that I mean to plug in n equal to 2. See, it currently doesn't know that. So here's what I'm going to do. I'm going to go back up to this statement, and I'm going to say n and dash and the greater than symbol, and dash greater than gives me an arrow, like so. Okay, and so now that I've got this arrow, I can hit enter on this statement again, and guess what? It now knows that if I write an expression like a parentheses any number, it will replace replace n with that number and evaluate it for me. Okay. Okay. The next thing we can do then is to find some points that can be plotted so we can look at the way this sequence behaves. So I'm just going to say that my points are equal to, this is a built-in command, seq, sequence, and the syntax for this statement, it's almost starting to get looking like coding, but we'll just type it in here. Okay, I've just defined an ordered pair. Okay, the square bracket defines the ordered pair. The first of it is n, that's going to be the x-axis, and a of n is going to be the y-axis. Okay. The next thing I need to know for the sequence is where to begin and where to end. Okay. What did I want to start with 0. The sequence I want has the factorial here, because 0 factorial is 1. That's what was going on. Okay, here we go. And that's fine. So let's try this statement again. We won't get a numeric exception for the division by 0. Okay, and look at this. This very messy expression is telling me that I've got 21 in fact, ordered pairs, and n equals 0, 1, 2, 3, 4, etc. are the first piece of that pair, the x data. The y data coming from evaluating this with n equal to 0, 1, 2. So these denominators are getting large because of the factorial is getting large. Okay, and we don't want to look at that mess, so I'm going to put a colon to suppress that. What we do want to look at is a point plot of the points that I just defined. And what I forgot to do just now is, again, to be very careful with my square brackets so that it knows I'm talking about a list of 2 ordered pairs. Okay. And so this is the range that we're getting. And if I just click on this graph, this is especially nice to know for printing your files and sharing them with people. You can resize these graphs so that they're more manageable and you don't have 30 to 40 pages of Maple output, and you can still see what's going on with the sequence. Clearly it's starting at 1, -1, and then it starts decreasing quickly, and it's oscillating quickly. Okay, so that's just the generic behavior we want to see from the sequence. And of course, the next thing we want to do with the sequence is study the limits. Okay, so we can make a statement like this. What is the limit of a of n as n goes to infinity? Or what's the limit at n equal to infinity, is the way Maple is interpreting this. Okay, and we get 0, right? Which is quite clear from the graph. The sequence is getting very, very small very quickly. The other thing we can do is, just like with the integration, if I put a capital L here, I can just show what the limit is looking like. Okay, and if we really want to be nice and fancy, we can put those side by side. Oops. Like this. So this is more of a statement now. It says that the limit is equal to, and then on the right hand side goes the value of the limit. Okay, so that's the way I'm going to leave that. That's a nice way to look at everything. Alright, and the next thing we want to do is define some, well, a partial sum. Eventually we're going to get to the series that is the infinite sum of this a sub n. And so what I'd like to do first is look at the partial sums, which, if we type in the following, we'll get that. Alright, so sum with a capital S this time. I'm summing this sequence, and I'm starting at 0 and I'm stopping at m. Okay, looks just like that. Alright, now to define the full series, what would have to happen here is I'd have to have m equal to infinity. Okay, so the way we can do that again is, now I'm going to take the limit on my partial sum with m equal to infinity. Okay, and this will just show me what the limit is. And I'm going to do the same technique here. I'm just going to evaluate the limit on the right hand side. Okay, and there you have it. Since this is related to the Taylor series expansion for e to the x, and we've got -1, the limit comes to be e to the -1. Right? I guess I'm not getting it to push this into a fraction to match that, but it is in fact the same exact number, is in fact the same exact value. So that's just a quick demonstration of how we can study sequences in series with Maple as well. And that should wrap up the tutorial. If you have any other questions, I'm happy to answer them, and if needed, I can make more videos to explain other things in depth.